Okay, we're going to do one more video in our series on optimizing assets from the marketplace. So this is the decay pack from Meshing Gun. Really great pack I just bought the other day. But there's some pretty high triangle counts and different stuff in it, so I'm trying to help reduce that and use it for my game. So this is going to be a particularly neat asset to showcase, I guess, because it's metal. So metal in my game is done with deformation, not destruction. So the concrete I showed in the last video is obviously using just chaos destruction, but metal typically doesn't destroy quite the same. It will at a certain point, but metal will typically deform before it gets destroyed. So I'm going to migrate this out to my optimization playground project. Close this, open that up. We have our mesh here again, which is 3 megabytes, my ass. 167.5 megabytes of memory. Most of it being the material, because 165.8 megabytes of it is the material. Only this little tiny chunk right here is the mesh itself. So that means the geometry is not like costing a lot in terms of memory, but it does affect you if you try to do things like, again, runtime vertex painting, or you want to do a skeletal mesh with it, which is what I want to do, because skeletal meshes can't have nanite. And if you had a nanite with 357,000 triangles, or turn this into a skeletal mesh and then use that for nanite, oh god, it's just going to be a mess. So don't do that. Turn off nanite on this, apply changes. You're going to get 357,000 triangles, which is a crazy amount. And if you saw before, the nanite fallback was 12603. So I can put that as my max triangle count here, and we're going to lose minimal visual fidelity. So this is with all the triangles. I'm going to apply the changes. Might take longer because it's a large mesh, so sometimes this can be a little chunky of a process. So again, very, very minimal fidelity loss whatsoever, and much, much smaller triangle count. So, and it's even still bent inside, which I think is over the top, but is what it is. Okay, so 12602, or 60, yeah, 12603, whatever. Do that. So now we have our mesh that is not so bad. Looks really good. Still high vert count, but not brutal. And high vert count's important for what I'm about to show you. So this is like decent. It's could be go down more probably, but kind of, you know, comes down to optimization per project and how much you can tolerate deformation on meshes when you lower the poly count. Because if you do it with software, you can generally get a better job than doing it in engine, and it's because you can select certain vertices and then reduce those certain ones, and that becomes more apparent when you're doing stuff that's planar. Like, let's say you have a chain link fence and you want the chain link fence to be able to deform. That plane that the mask is on that represents that chain link fence, in order to have a deformation appearance to it, is going to have a high poly count in order for it to like push itself and look like it actually bent instead of looking like bad geometry. So the next part about this is really cool is now we have this. But if I right click on this and convert it to a skeletal mesh, because of the skeletal mesh editing tools that comes with this now, with the editor plugins, you'll get a skeletal mesh that's just a root, and you can add bones to this with this tool, with the skeletal mesh editing tool, as well as you have this. But if you notice, there's a little yellow there that says there's no physics asset. That's something you immediately want to resolve. Just create and assign one, even if it's basic. You just want it because otherwise it's going to be confusing later. So this thing will just kind of, you know, give you a really basic box around this. If I was making this asset, I would make it so I could walk inside, so it would actually be, you know, 4 boxes that I would scale, or whatever, however many boxes to make the shape. But now we have this. So the next part of this tool that's pretty neat is you have all these, which are skeletal mesh editing tools. And this can be nice because there is a remesh feature right in here, which I don't even know if I should have clicked on, but it shows you the triangle count and all that other jazz. We're not going to do any of that stuff right now. I'm going to close that. And this is the Morph Tools, Morph Power Tools. This has a ton of features, things I'm not even going to get into, but it's a great plugin from what I've seen so far. And just right off the get-go, I'm going to create one called Morph Test. And that's just because that's the function that I have set up. So I'll show that off in a second. I don't know why it does that to textures when you do this. But we're going to do sculpt. Change my brush size to be, make it a little narrower. And I mean, it is important to note the shape of what you're doing. So like the shape of the deformation obviously doesn't match being smooth. So doing something more linear might be a better idea. But I'm just going to do a basic, like, oh, that's a huge line. And sometimes it acts weird, and I don't know. Oh, I think it's because I have it on that instead of viewport. When you have it on normal, it can be funky. Yeah, there we go. So I just deformed the mesh like generally like that, just to show you. Obviously in this, if you were doing this in an advanced setting, you would create a bunch of morph targets, and those morph targets would be associated to bones. And then the closest location to that hit bone, you would get the morph target of and deform that. I don't know if I can show a really quick example of that, but obviously you can see that now we have the morph targets. Oh, cancel. I want to save the changes of this. I always forget to do that, so do that. Okay, so now we have our container, and if you look at the morph targets, you can adjust them, and you'll see them womp, womp, womp. So, pretty cool. And then you just build functionality into your character or into whatever event that you choose to do this. So, again, usually what it looks like is something like this line trace, where all it's doing is just getting a very basic aim vector from my camera, forward, doing a line trace, sends that data out. This is not really an ideal function, but works. It is a right mouse button to set a timer, which is whenever it's held. It's starting a timer that's looping. It's just going to line trace, and if it hits anything like a skeletal mesh component, it's going to set the morph target of morph test to 1, and then whenever it's not hitting anything, it's going to clear and invalidate that timer, and then just set the morph test down to 0. So it'll just kind of pop and unpop something. The other way would be, you know, obviously if you set it to a negative value, it pops the opposite direction. So we have that, and then we'll create, where is it now? We have our container. So again, the good thing here is if we look, oh, what the heck? That's not right. Something strange happened here. Yeah, I'll figure it out after. Anyway, this pop, pop, and you can see that it does bend in the inside, which means that if you were to do this in an ideal world with something really, really complicated, you'd want it to handle collision, because this is not going to handle collision, and I don't know if I can see that without going into this. No, it won't let me show it at the same time. But yeah, it's not actually changing the collision. So you can see that I can't jump into the dents, obviously. There is ways to do that with modified vertices from the morph targets. So like, because your morph targets are modifying the vertices of the object, you can dynamically recalculate collision with that, but it can get complicated and expensive in that in an ideal world, again, you would want to have a subsystem that asynchronously does that so that it's not so hard on your game thread. Because otherwise recalculating collision is going to crush you. All right, so I hope that helps some people. I did notice something in this video, but if I figure it out, I'll come back and make a follow-up video. So yeah, hope that helps some people.